Okay, now that we have discussed the topology and the value it brings, another capability I just want to touch upon, which is really interesting, is the ability to build new spokes, transits, VPCs, all in a very visual and easy to consume way. So basically, all what you need to do is to select a cloud region. I have, for example, AWS onboarded. I have two accounts, but I'll use the AWS account, and I can choose, for example, a region. Okay, now that I've saved this, the next step is to go and start creating a spoke gateway. If we don't have, you can either choose a VPC that's already there, or it even gives you the option to create a new VPC. Okay, so you can give that VPC a name. I'm just going to do it for the test purposes and give it a side range, just an example, really. And sorry, I probably put an additional 0. Yeah. And let's do a /16, if that works. And this now, by doing this, this is actually creating the VPC in AWS in that particular account with the name of test and with the side range of 11/16. It also creates subnets, internet gateways, and various other objects within the CSP, which is AWS in our case. We'll just give it a minute for the API to actually happen and for the creation to be completed. Okay, now that the VPC has been created, you can launch this spoke gateway within that particular VPC. You can give your gateway a name, say test spoke. Again, all of these names, I mean, we probably in a production environment, we need to choose better namings. And then the gateway size, obviously, this is also another topic to look at, and whether you want high performance encryption or not. And now this is the other question, is how many gateways do you want to create? So you can create one gateway. This is the gateway icon. And we're going to allocate an elastic IP. And then I can choose, for example, a gateway in US West 2A availability zone, and then I can do in 2B. And then I can keep adding gateways in C and D. And I can even connect it to one of the transits that exists today, or I can go and create another transit. So I can save this. And now, by the way, I can also click on transit and start doing the same. Or I can tell it, you know what, deploy it, or give me the Terraform for everything I've told you to do. So notice that it's creating a spoke gateway with the VPC, that has already been created. This is the VPC that we did create. This is giving us also another spoke gateway because we created multiple instances of these gateways. So we can say spoke HA gateway 1, spoke HA gateway 2. So all of these 3 gateways with the size T3 small are going to be created within that particular account in the US West 2 region in the VPC that we have already created. You can download the script or copy it to clipboard and then paste it in your IDE of choice. Okay, I just wanted to show you this because this is a really nice and easy way to create topologies and gateways, and makes things much easier to consume. And if you want to get the Terraform just to get started, to gain more expertise in Terraform. So I'm going to just reset because I don't want to create this, but I just wanted to touch upon this. Gateways is another interesting menu. One thing to notice is when we talk about gateways, we look at, generally there is a concept called gateway groups. So Aviatrix moved a bit from gateways to gateway groups. Unfortunately, here all I have are single items, but let me just try to show you another setup. Just give me a second. Yeah, so this is another setup. I just wanted to show it to you to explain the concept of a gateway group. So especially the ones that have multiple gateways, it will be a bit more obvious. But basically, whenever you open a gateway group, this is a gateway group, and inside the gateway group lives gateways. So you can see that the name of the group is AWS Spoke 1, and then I can launch multiple instances within that group. So all of these gateways will have the same exact configuration, the same exact properties. When I attach them to the transit, all of them will attach to the transit. So the idea is, instead of dealing with on a configuration management perspective from a gateway to gateway perspective, what we do is we have a gateway group, and the gateway group actually can have a number of gateways within that group. Actually, for spokes, we can have up to 15 spoke gateways within a VPC and within a gateway group. For transits, the limit today is 2 per VPC. Okay, so I just wanted to explain this. So again, whenever I click on add a spoke gateway, this is the gateway group. And if I were to create the instances, this is where the gateways are being created. Okay, so obviously because I don't see anything because I have to specify the account and then choose a region and then choose a VPC, choose an instance size, and I can attach it directly to transit. And then this is where I can start creating the gateway instances one by one. Okay, so all of this, I just wanted to allude to the fact that we now leverage the concept of gateway groups instead of individual gateways. The reason you don't see it here very clearly is because each of these gateways actually has a single instance. So you cannot clearly distinguish the gateway groups versus the gateways. Okay, but if you open it and you have you will see a single instance versus if you opened the one I was showing you and looked at the instances, you will see that there are 2 actual gateways. Each one lives in an availability zone. Okay, so now within Copilot, you are able to create the spoke gateways. My apologies, I'm going back to our setup. So we can create a transit gateway. You can choose all the attributes if you want to peer to other transit gateways and how many instances. As I mentioned, for transit gateways, you will see that beyond 2, the instance icon is actually grayed out. So you are not able to create additional instances, versus when I go to spoke gateways, you can see that I am able to create much more. Now we are at 11. I believe the number should finish at 15. Exactly. So now at 15, the instance icon is actually grayed out. Okay. So all of these can be created. Now there are also the other types of gateways. Things like if you're having a VPN setup, or you're having public subnet filtering, or other types of standalone gateways, these will show up here. They are not spoke and not transit gateways. So in this example, they are egress gateways. They will be shown in these under specialty gateways. The final piece is the gateway management, which basically allows us to upgrade the controller, upgrade the gateways, and handle all upgrades, even image upgrades for the gateways, all from that page. We're not going to discuss Edge, but Edge basically is extending the Aviatrix fabric into the edge of your network, which could be Equinix, could be your data center, could be any branch that needs connectivity to the multi-cloud environment. There's a ton of benefits in the fact that Edge is treated like a spoke. There is no need for IPsec. There is also the benefit of high performance encryption, and leveraging the same operational benefits of Aviatrix, just extended to the edge. Connectivity is also one of the new the new functionalities that has been added into Copilot. It used to be within the controller. So you're able to create an external connection. This is, think about it like a site to cloud, and you're able to decide if you want to do it. First of all, you need to decide what is the encapsulation. Do you want to do IPsec? Do you want to do GRE? Do you want to do LAN? You can also choose to run BGP, or you can even run, oh, my apologies. You can even run static routing on top. Okay, you obviously need to decide what is the local gateway, meaning what is the gateway in your actual setup that terminates it. So if you do, for example, static, the reason for the BGP you're not actually seeing the gateways, the spoke gateways, is because our spoke gateways actually are not having the our spoke gateways are not running BGP. So if you look at the spoke gateways, just again navigating back, one of the items that that you need to specify upon creation is whether you want to turn BGP on or off. So this is a bit on site to cloud. And so you can see here a connection on-prem DC, it's BGP over IPsec. The other one is a static route-based. It's also a map NAT, which I'll explain. These are the remote gateway IP addresses. Finally, there is scaling. This is a very interesting feature that v23 came up with recently, part of which I think is still in private preview, if I'm not mistaken. So if you click here, you can see, yeah, so manual scaling is out of preview. However, it seems like automatic scaling is still the one that is in preview. The idea, before we get into the different types, the idea of scaling is twofold. You can either do what is called vertical scaling. And vertical scaling is a very simple logic. Basically, you have an instance, maybe you're running again in AWS, you're gonna do a T3 micro, and suddenly you're having a demand or more load on your workloads and applications and gateway. So what we can do is we can basically increase the gateway size to for example, a T3 medium. Again, by monitoring certain metrics, whenever they exceed a particular threshold, we are able to change that instance from a T3 micro to a T3 medium. One point to note, though, is that during the change, there is little disruption because we don't actually change the same instance. We launch another instance, and whenever the new instance is up and running, we change the routing table of the VPC router. And before it was pointing to the T3 micro instance, and we tell it, you know what, now we're going to point to the T3 medium instead of the T3 micro. So this is, in a nutshell, what vertical scaling is about. And this is also another expression you'll find is scale up and scale down. These generally mean, so if you see vertical scaling, scale up, scale down, these generally are talking about the same thing. Scale down obviously is when you no longer have that load, you might want to go back to the original instance size. And then there is horizontal scaling. Horizontal scaling is more along the lines of you have an instance. Again, let's assume it's a T3 micro. And instead of changing that instance size, you launch another instance, which even could be in the same AZ, so that both of these instances can actually carry the load. Okay, so this is what is called horizontal scaling. You might also hear the words scale out and scale in. These all mean, generally they are referring to horizontal scaling. Okay, so That is the concept. And now when you do click on the policies, you will see somehow the same thing. There is 3 types of scaling today. There is the manual scaling. Manual scaling, the way I would like you to think about it is we are going to notify you that we have a recommendation for you to scale. We're not gonna do the scaling for you. We want the user, the administrator in this type of scaling to actually take the scaling action. All what we're going to do is we're gonna tell them that the trigger conditions for that scaling event has happened. Okay, so you can see which spokes. You can do it for spokes. You can do it for transits. That's, for example, if I do all my spokes, and I say that whenever the CPU exceeds, I don't know, 78%, I'm just giving a number, I can add another condition and say, you know what, maybe if I am dropping packets, for example, so packet drop rate is more than something, let's say it's 5. I'm just giving, again, an example. You can make it an OR, so you can decide how you have multiple groups, and then you define also. You can make the logic as complex as you need. And then the other thing that is important is to evaluate how long do you want that condition to persist, because maybe you do not want to react to a sudden peak in CPU, for example, or a packet drop rate that is very, very, that lasts for a few seconds and then goes back to normal. So the evaluation period is basically saying we want this to sustain for around a period of 10 minutes. And then this is where we will take the recommendation. We will basically inform you that we suggest that you scale. So you're going to have, again, scale up, scale down are about vertical, scale in, scale out are the horizontal. And what's important, obviously, for this to work is you also need to send the notification to either a webhook, which could be anything. It could be a ticketing system, could be Slack, could be Teams, could be whatever system that you are trying to integrate with, or even it could be an email, so that the administrator comes in and takes the scaling action. Now, on the scheduled scaling, this one is really nice, especially if you're preparing for an event, preparing for a launch of a new app, or expecting a sudden peak because of an advertisement, or whatever you're doing. You can basically add the VPCs, and you can say, I want to scale on maybe Monday between 9 and, I don't know, expecting something between 9 and 2. And again, you can send the notification. The difference in this case is we are actually doing the scaling for you. We are not sending recommendations. Okay, manual scaling is the only one that sends recommendations. Scheduled scaling, meaning I want to scale out at this time, and I want to scale in at this time. Worth noting, because of scale out and scale in, that this is a horizontal scaling action, and there is no vertical scaling, at least as of today, as of the time of this recording, for scheduled scaling. Manual scaling had both options: scale in, scale out, scale up, scale down. Automatic scaling is similar to manual scaling. However, the idea is we don't want you to worry about scaling. We're going to say that if the CPU is between, if the CPU is basically goes above the that particular range. Sorry, yeah. Basically, if the CPU, for example, here is anywhere between 20 and 80, maybe there's not something that you want. Maybe you would do it between 70 and 80, for example, or you can do it 70 and 100, anywhere basically above 70. And you can even add another condition as we did before. You can add or, but here you'll notice the metrics are much less than the manual scaling. So we can look at CPU and or memory. And again, you have the evaluation period. The difference, as I said, with manual scaling is we will take care of the scaling for you. Again, this is a scale in, scale out. This is horizontal scaling, not vertical scaling. The only one that offers vertical scaling today, again, as of this recording, is manual scaling. Scheduled and automatic are about horizontal scaling. This is the page if you had the manual scaling where you will see the recommendations. Other than that, scheduled or automatic all do the scaling by themselves. There's no need for any recommendations. And events is the place where you will see the events. Let me check if I can show you something. Go to scaling. Yeah, so this is how a recommendation would look like. Again, it will tell you that maybe you can actually go and scale it down. The other one would be the events. If we had done the scaling, you will see that the scaling event would actually be recorded under the events. Network segmentation, we're going to have a lecture on this, so I'm going to skip it. Distributed firewalling, we're also going to discuss this, so I'll leave it till the end. Threat IQ is an interesting functionality. I'll just explain it and enable it. So I need to configure recipients first. Let me put an email address and let me put Kareem, for example, and put ace@v23.com or ace.lab, whatever email. Basically, I just do not want to receive emails on my email. And then I can go back to Threat IQ and say, you know what, when a threat is detected, I'll explain how it works. You can send an alert and you need to add a recipient, and this is the email you're going to send to. And I want you to block the threats, and these are all, you can decide which VPCs you want to protect. So these are all the VPCs that we want to actually protect. And this is just enabling Threat IQ and Threat Guard. Now, the way it works is very simple. What happens is let me check if I can see any traffic. Yeah, so the way it works is all of our gateways, they send flow information into Copilot. Okay, so whenever a packet traverses the gateway, that metadata of the packet is being sent into Copilot. So let me try to visualize something. So you can look at a Copilot like being a repository of all, and whenever packets go through gateways, okay, you have, again, sorry for my drawing skills, but whenever the packets are actually passing through these gateways, the gateway is sending a metadata of the packet that actually went across into Copilot. So even for a single packet that goes across 4 gateways, in Copilot, you will see 4 different views, because these 4 gateways actually sent the flow information, the metadata information into Copilot. So this is assuming this is Copilot. There is an app within Copilot that is called Flow IQ, and this is where this, if you want, it's basically provides analytics, visualization, and search capabilities on top of the data stored in Copilot. And there's a lot of value, which we will discuss as we go across the labs. But if you see, I can search, for example, I can zoom in on a source IP and see who is this source IP talking to. And I can see, for example, it's talking to a particular public IP, and I can look at the source port, destination port. This looks like a web traffic. I can see which gateway actually saw that packet, and we'll discuss why this is very important and why is it very useful. And I can go and check the record itself and see where did this gateway get it on, which interface, where did it send it to, all of this information can actually be seen. And I'm able to obviously change the time. So if an incident happens and something changes, you're able to go back in time and see how did the gateways deal with or forward a particular traffic. You can also see something like this autonomous system belongs to Microsoft. So this might give you additional information. There's a lot of fields, by the way, to search on. I can make the search as interesting as I want. You can see the metrics. There's a lot of metrics. You can even search by the city name, country name, things like protocol, things like layer 7 protocol name, all of these details. And if you go to records, by the way, and you go to the columns, you'll be able to add all of these fields or whatever fields. For example, if you want to see the protocol layer 7 protocol name, right? And if you go now, I just added it, and it is protocol name is actually TCP. If you go and look at layer 7 protocol, I just added it, and layer 7 protocol is not detected for that one for a particular reason. So again, I'm able to choose anything I want and just get more insight on the information. Okay, so the reason this becomes important is Aviatrix, on the other hand, wants to provide a secure networking experience. So we subscribe to Proofpoint. Proofpoint is one of the most known sources on the internet for threat intelligence. The idea of threat intelligence is very simple. The idea is that if I know of an IP or a domain that has done bad somewhere in the world, I want this intelligence to be shared with everybody in the community so that these same the same exploiters are not able to successfully conduct the exploit from the same premises, if you want to think about it this way. Okay, so the idea is we share this intelligence worldwide, and you, being an Aviatrix customer, have access to this. So because we have Flow IQ, we have a database of every single packet that crossed our gateways. So the end result is we can check if these source and destination IP addresses are known to be malicious. If they are known to be malicious, we can send you an alert, which is what you saw me with when I was configuring actually Threat IQ. So again, this is, I just enabled it, so it takes time. But basically, as I mentioned, I told it to send the alert and block the threat. And this is where you can get a webhook or an email or whatever that you have a threat. And if you configure it to block the threat, we will automatically program the firewall rules within the gateways to actually block traffic to this malicious IP address. Okay, let me check if I have it on the other dashboard. Yeah, so here you can see it actually already enabled. So you can see how many threat IPs actually visited in the last 24 hours. And you're able to see everything that happened. Anything that shows in red is a malicious IP address. And if you click on any of those, you are able to see the flow data. And if you want to see the full net flow, you're able to see the whole packet of what was the source address, what is the destination address. This is the source address. It seems to be within your network. And the destination address is the malicious address that is known to be malicious. So something within your network is actually communicating to a malicious address. If you want to know why is this considered a threat, you are able to go and to see. So this is a poor reputation IP, and there is a certain severity also that is conveyed. We're also working to make more, to make this a bit more consumable and provide more context on why a threat was considered actually a threat. The other piece is now if you go to configuration, because we have configured not only the alert sending, we have configured the threat blocking. What you will see just in a second is we have programmed, for example, a number of rules and basically the number of threats blocked on each gateway. So if I open the gateway, these are basically the firewall rules that have force drop action. We have dropped the traffic and we drop it in both directions. If traffic is going to a malicious IP or traffic is coming from a malicious IP, we want to ensure that no communication is possible with those malicious IP addresses. The reason you see 64 and you saw 32 IPs is because for every IP, we are programming two rules, one in each direction. Okay, you can also add some custom additional threat IP addresses that you might know from other sources to enrich your data. So this is all possible. If you want to do geo-blocking, this is also a new feature whereby you are basically blocking a complete country, again, based on geo IP, from going through any of your gateways, okay, which is a really cool feature. The other thing that I really like is we tell you before you block a country that if we have seen IP addresses that are coming from that country. Okay, so all of this can actually be we can see within the geo-blocking feature. And if you're interested to figure out these IPs, so again, when you went to geo-blocking, I just want to open it in another tab just to show you what I'm talking about. So this was, for example, in Argentina, we had 62 IP addresses, right? And if I go to, I want to see those IPs, right? I'm able to go and put search by geo country name, Argentina, and see the different IP addresses. Okay, just if you, in case anybody's interested to figure out to see those particular flows, and if you want to zoom into any of those, again, you can look at the exact records and see what happened. Okay, so now that we've talked on Threat IQ, we'll discuss egress again in a later lab. We'll also discuss FireNet in a later lab. Just choosing if there is anything interesting. Flow IQ I've already talked to you about. App IQ is another interesting tool whereby you're able to choose. There's a tool within App IQ, which is Flight Path. So I can do BU1 front end, which is one of the VMs, which I'll show you in a minute. And there is the BU2 mobile app. And I want to check if these two instances can communicate over ICMP. And I tell it to run the report. What is interesting about this is it gives us everything it knows from the CSP, from a v23 point of view, to try to figure out if these two instances or these two endpoints can actually communicate with one another. It gives us a very interesting report showing the instances. These are the two ones I've asked about, the VPCs and the gateways that are in the path. So it could, for example, the spoke 1 BU1 front end is part of the spoke 1. The spoke 1 connects to the transit 1. Again, these are in EU. And then the transit 1 connects to the spoke 2. Again, all of this is in the same region. That's why you can see very short latencies. And then the packet goes to the instance. So if I were to go down, I will see the latencies. And I will see is there anything wrong with the gateways at that particular point in time? What was I having packet drops? Was I having enough memory, disk, anything that looks, because again, these things could basically be a cause for a dropped packet. And then after this, you can start seeing if they should be allowed to communicate with each other. So it looks at the network ACL, again, from the first instance point of view, which is BU1 front end. It says the network ACL passes because we have an outbound rule that allows anything. The route table is okay because we have a 10/8, which is for destination security group. It looks at the Aviatrix spoke gateways route table, and it does the end-to-end analysis. And generally, if you wanted to do it on a CSP, you would have to open 7 to 8 tabs and try to stitch the information together versus showing you everything on a single pager. And if you want to get it in a PDF format, you are able also to actually get that. Yeah, so I'm not going to be waiting for it to actually do it. Now it did download the report on my laptop. And then the cloud routes is another interesting one because it allows you to see the gateway route tables, our gateways. In addition, it allows you to see the VPC, VNet route tables across AWS, Azure, GCP, all in a single pane of glass. And you're able to filter, for example, by name, by cloud. If I choose, for example, cloud equals, I don't know, GCP, and I have a single route table within that GCP, I can look at it. So I can do a lot of filtering. And again, it shows me everything from the gateway routes to the VPC routes. If I have a site to cloud connection, which is an external connection, I'm able to see if that IPsec tunnel or that particular connection is actually up or down. I'm able to get more details on what is my peer IP address, what is my IP address, what is the tunneling protocol. The same for the other one. And if I'm running BGP, which is a very interesting feature, I'm able to see the BGP status. So the BGP status is established. This is the neighborship. These are the neighbor IPs over the 169.254 addresses. I'm able to see a BGP map, which is very nice. It shows you the remote side, which is called, the connection is called on-prem DC, coming to the Aviatrix transit. I am in AS number 65011, they are in 65012, and I am able to see what are the routes I'm learning from there, and I am able to see what are the routes that I am actually advertising to that site. Okay, I think this was a fair overview of the of Copilot. Again, there are still some remaining things that we will explore in the upcoming labs.